children. Now let us study about inner transition elements or F block elements. F block elements are placed at the bottom of the periodic table in two rows. It consists of two rows or two series of elements called lanthanoids and actinoids. The first row elements, there are 14 elements which are called lanthanoids. Second row of elements, again 14 elements which are called actinoids. These elements actually belongs to 6th and 7th period of the periodic table. Lanthanoid belongs to 6th period. Lanthanoids are actually 6th period elements. Actinoids are 7th period elements. And these 14 elements, lanthanoids, 14 elements, actinoids, show similarity in their properties. And in order to avoid the length of the periodic table, these 14 elements, lanthanoids and actinoids, have been taken from the main periodic table and arranged at the bottom of the periodic table in two rows, that is F block. Why these elements are called F block elements? Because in lanthanoids and actinoids, F atomic orbitals are filled with electron. In the case of lanthanoids, 4 of atomic orbitals are filled with electron. Hence, this is also called 4 of series. 4 of starts filling with a cerium. Lanthanoids are cerium to lutetium. 4 of 1, cerium, the configuration starts with a 4 of 1. And the 14th element is lutetium. Lutetium, the electronic configuration will be 4 of 14. That is, F atomic orbital starts filling in cerium and it is complete with 14 electron in lutetium. Actually, these 14 elements come after lanthanum. Lanthanum of the 6th period. Symbol La with atomic number 57. So after lanthanum, 14 elements have been taken from 6th period and arranged at the bottom as the first row of F block elements. That is lanthanoids. Since they come after lanthanum and they show similarity, they are called lanthanoids. Why these elements are called lanthanoids? Because they come after lanthanum. Study of lanthanum is also done along with lanthanoids, because the chemistry of lanthanum, lanthanum resemble lanthanoids in its properties. So the chemistry of lanthanum is also included along with the study of lanthanoids. Even though lanthanum contains no 4 of electron, the lanthanum resemble in its properties with the lanthanoid, and lanthanum also study properties of lanthanum also we study along with the lanthanoids. Similarly, actinoids, the second row of elements, starts with the thorium and ends with the lawrencium. Thorium atomic number 90 to lawrencium atomic number 103. In these elements, 5 F atomic orbitals are filled with electron. F atomic orbitals are filled with electron. That's why the name F block. In actinoid, 4 of atomic orbitals are filled with electron. In the case of actinoids, 5 of atomic orbitals are filled with electron. Then these are called 5 of series. Actinoids also known as 5 of series. Here in thorium, it starts with a 5 of 1. And lawrencium, the last element, 14th element, the 5 of atomic orbital is complete with 14 electron. These elements, actinoids, come after actinium of 7th period. Actinoids belongs to 7th period of the periodic table. They come after actinium. Actinium atomic number 89. That's why these elements are called actinoids. Actinium resemble in its properties with the actinoids. So the chemistry of actinium is also studied along with the actinoids. So lanthanoids and actinoids, these are actually 6th and 7th period of the periodic table. In order to reduce the length of the periodic table, they have been taken from the main periodic table and arranged at the bottom of the periodic table in two rows. First row lanthanoids, second row actinoids. 4 of series and 5 of series. And the electronic configuration of lanthanoid, we told 4 of atomic orbitals are filled with electron. Here they are 6th period element, so the outermost shell is 6th shell. 6s2 is common for all lanthanoid. And before 6s2 the penultimate shell, that is 5d. 5d 0 to 1. In most of the elements 5d is empty except a few which contain 1 electron in the 5d. Electron is filled in not the last shell, not the penultimate shell, but the shell before. This is called anti-penultimate shell. In lanthanoids and actinoids, electrons are filled in anti-penultimate 4 and 5 atomic orbitals. So the general electronic configuration of lanthanoids can be written as 4 of 1 to 14, 5d 0 to 1, 6s2. In the case of actinoids, actinoids belongs to 7th period of the periodic table. So the outermost shell is 7th shell. Period number and valence shell number are the same. So 7s2, then inner shell, penultimate shell, that is 6d 0 to 1. Then electron is progressively filled in 5 of atomic orbital, that is 5 of 1 to 14. This is the general anti-penultimate shell. Electron is filled in anti-penultimate 5 of atomic orbital. So this is the general configuration of actinoid. General configuration of F block elements we can draw. How to draw? Outermost shell number is n. ns2 is common. Then inner one, n minus 1, d 0 to 1. Then anti-penultimate, that is n minus 2. n minus 2, f 1 to 14. This is the general electronic configuration of F block elements. And just like we studied, certain configurations are extra stable in the case of transition elements. Here also some configurations are extra stable, that is F0, empty F atomic orbital. Empty F atomic orbital. Then F7. F7 means F atomic orbital there are 7. So 7 electron in F means half filled F atomic orbital. Then F14. F14 means fully filled electronic configuration, fully filled F atomic orbital. So these configurations are particularly stable in the case of actinoids and lanthanoids also. And the study of these lanthanoids show mainly one oxidation state, that is most stable oxidation state of all lanthanoid is +3. Most stable state of actinoid is also +3. But actinoids show a wider range of oxidation states than lanthanoids. Study of actinoid is complicated because of two reasons. One reason is because it shows wide range of oxidation state. Means multiple oxidation, more number of multiple oxidation or variable oxidation states are shown by actinoids. Then another reason why the study chemistry of actinoid very difficult is all actinoids are radioactive elements. All actinoids are radioactive. Because of their radioactivity, their studies are difficult. So because of these two reasons, the chemistry of actinoids is very complicated. First reason, it shows wide range of multiple oxidation state. Common oxidation state +3 ആണ്, but it show, in addition to +3, it show a number of variable oxidation states also. And the second reason, these are radioactive. So their chemistry has not been studied much.